So how's it all gonna end? I don't just mean our planet or even our solar system. I mean everything, the whole show, the entire universe. Today, we are diving into the ultimate fate of the cosmos, according to what physics tells us.
That is a huge question, right? We know for a fact the universe exploded into being with the Big Bang, about 13.8 billion years ago? So it only seems natural to ask if it's all heading towards some kind of grand finale. And what's so cool is that physics doesn't just say, well, maybe. Oh no, it gives us several incredibly detailed, absolutely mind-bending scenarios for how existence itself might just stop.
Yeah, based on everything we know about the universe, our best theories point to five main ways this could all play out. We're gonna walk through every single one of them, from the really slow and quiet ones to the super sudden and violent ones. So let's kick things off with the current frontrunner, the one our data points to as the most probable ending, a long, slow fade into absolute darkness.
So this first scenario, it actually goes by a few different names. You might hear it called the Big Freeze or the Big Chill, but its official, more scientific title is heat death. And right now, this is what most cosmologists think is going to happen if the universe just keeps on doing what it's doing, which is expanding faster and faster.
Now, I know what you're thinking. Heat death sounds hot, but the name is actually a little misleading. It doesn't mean the universe ends in some epic blaze of glory. It's actually the exact opposite. See, it's a physics term for when everything reaches maximum disorder, or entropy. Just try to picture all the energy in the entire cosmos spreading out so thin, so evenly, that nothing interesting can happen anymore. No stars can form, no life can exist, no movement. Just a cold, perfectly uniform and eternal stillness. And the timeline for this, well, it's almost impossible to wrap your head around. In about 5 billion years, our galaxy, the Milky Way, is going to merge with our neighbor, Andromeda. But that's just the very beginning of the end. Fast forward to 100 trillion years from now. By then, every last star will have burned out. The universe will be plunged into what they call the degenerate era. The only things left will be the cold corpses of stars. And you know what? Even those don't last forever. Just look at this number. That's a googol, a 1 followed by 100 zeros. That's roughly how long it could take for a single giant black hole to just evaporate into nothing because of Hawking radiation. After the very last one is gone, the universe enters its final stage, the dark era, a vast, cold, empty void where literally nothing happens forever. Okay, so a slow, quiet fade to black is the most likely ending. But what if it's more dramatic? What if it's more violent? There are other theories that suggest the universe goes out not with a whimper, but with a bang. Or, a rip. Or a crunch. These two possibilities are basically cosmic opposites. In one corner, you have the big rip. The idea here is that the dark energy that's pulling our universe apart just keeps getting stronger and stronger, until it becomes this phantom force that literally nothing can stand up against. It would tear apart galaxies, then solar systems, then planets, and in the final terrifying moments, it would shred the very atoms that you and I are made of. And in the other corner, the big crunch. It's the complete reverse. Gravity finally wins the cosmic tug of war. It stops the expansion and starts pulling all of existence back in on itself, all the way back into a single, infinitely hot point. Basically, the Big Bang, but in reverse. Now, if you thought the big rip and the big crunch sounded pretty wild, well, they have absolutely nothing on the possibilities that bubble up from the bizarre world of quantum mechanics. These scenarios, they're not about gravity or dark energy. They're about the fundamental stability of reality itself. Okay, this one has to be my favorite. It's called vacuum decay, or the big slurp. The theory is that the Higgs field, the energy field that gives particles their mass, might not actually be in its most stable state. It could be in what's called a false vacuum. Think of it like a coffee cup sitting right on the very edge of a table. It's stable for now, sure, but the tiniest little nudge, or maybe just a random quantum wiggle, could send it tumbling to a lower, much more stable energy state on the floor. So how would this actually go down? Well, somewhere out there, a tiny, tiny patch of the universe could just spontaneously tunnel into this true vacuum state. And from that one point, a bubble of brand new reality with completely new laws of physics would expand outward at the speed of light, instantly rewriting or destroying everything it touches. And because it moves at light speed, we would have absolutely no warning. One moment, the universe is here. The next, poof, it's gone. But wait. What if the end is also a beginning?
That's the whole idea behind another theory called the Big Bounce. It suggests that if the universe did end in a big crunch, it wouldn't be a final crushing end. Instead, the weirdness of quantum physics might force a bounce, triggering a brand new Big Bang. In this model, our universe is just one in a potentially endless cycle of creation and destruction, born from the ashes of the one that came before.
So, after exploring all these truly cosmic endings, you might be sitting there thinking, okay, but what's the point? Why are we thinking about fates that are trillions upon trillions of years away if they even happen at all? Well, it's because thinking about the end of everything is one of the best ways we have to understand the universe as it is, right here, right now.
The cosmologist Katie Mack put it perfectly. She said that asking about the ultimate evolution of our universe actually tells us a whole lot about what's happening today. Pushing our scientific theories to their absolutes, breaking limits, all the way to the end of time itself, is how we figure out if they're right, or where they fall apart.
At the end of the day, these really aren't just cosmic bedtime stories. Each one of these scenarios is a powerful test. You see, vacuum decay connects the tiniest subatomic particles to the fate of the entire cosmos. The Big Rip forces us to get a better handle on dark energy. The Big Crunch challenges our understanding of gravity itself. This whole exercise, it's the ultimate stress test for all of physics.
And all of this leaves us with one last big thought to chew on. Whether it's a freeze or a rip or a bounce, is the end of the universe truly an end? Or is it just the universe changing the rules, shifting into some new state of being that we can't even begin to imagine? The answer really gets at the very definition of existence. And honestly, it's a question we'll probably keep asking for as long as we're here to ask it.